Division is the reverse operation of multiplication. Like numbers, can we divide a polynomial by other polynomial? Let's try it and divide a polynomial by the monomial. We can see that in this polynomial, x is common to each term. Therefore, it can be written in this way. That's why these are factors of this polynomial. Now, by cancellation, we get quotient 4x square plus x plus 1 and the remainder 0. We can express this as dividend is equal to divisor multiplied by quotient plus remainder. So here 4x cube plus x square plus x is the multiple of x and 4x square plus x plus 1. Now, can you divide the polynomial x square minus 3x minus 10 by polynomial 2 plus x? Let me tell you, for dividing this, first we will arrange the terms of dividend and divisor in descending orders of their degrees. That is, we will write them in standard form. Now, we will divide the first term of the dividend by the first term of divisor. Here, we will get x as first term of quotient. After this, we will multiply the divisor by the first term of quotient and subtract its product from dividend. We get minus 5x minus 10 as remainder. Now, the remainder minus 5x minus 10 is a new dividend, while the divisor is same. So, like the previous step, we will divide the first term of dividend by first term of divisor. We will get minus 5 as second term of quotient. Now, we will multiply the divisor by second term of quotient and subtract its product from dividend. This gives 0 as the remainder. In division, we have to continue this process till the remainder is 0 or degree of new dividend is less than degree of the divisor. So now remainder is 0 and sum of quotient, that is x minus 5 is whole quotient. We can express this as dividend is equal to divisor multiplied by quotient plus remainder. So we can say that if p of x and g of x are two polynomials such that the degree of p of x is greater than or equal to degree of g of x and g of x is not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x multiplied by q of x plus r of x, where r of x is equal to 0 or degree of r of x is less than the degree of g of x. That is, p of x divided by g of x gives q of x as quotient and r of x as remainder. Now, in this polynomial p of x, if we replace x by minus 2, then we will get 0. That is, the remainder obtained on dividing both these polynomials is same as the value of polynomial at 0 of the polynomial. This fact is generalized in the form of theorem called remainder theorem, which states that if p of x is any polynomial of degree greater than or equal to 1 and let m be any real number, if p of x is divided by the linear polynomial x minus m, then the remainder is p of m. Let's verify this. Let's consider p of x as polynomial with degree greater than or equal to 1. When p of x is divided by x minus m, q of x is quotient and r of x is remainder. So, can we represent it like this? The degree of x minus m is 1 and degree of remainder, that is, r of x is less than degree of x minus m. Therefore, degree of r of x is 0. A constant has degree 0. So, we can say that r of x is a constant, suppose r. Therefore, for value of x, r of x is equal to r. So, we can write p of x is equal to x minus m, q of x plus r. This proves the theorem. By using this theorem, we can easily find the remainder when two polynomials are divided. Now, let's understand factor theorem. which states that if p of x is polynomial of degree n greater than or equal to 1 and t is any real number, then x minus t is a factor of p of x if p of t is equal to 0 and p of t is equal to 0 if x minus t is a factor of p of x. Now let's prove it. By remainder theorem, we can represent it like this. If p of t is equal to 0, p of x is equal to x minus t, q of x. This shows that x minus t is factor of p of x. Since x minus t is a factor of p of x for the same polynomial hx, so in this case, p of t is equal to 0. Therefore, we have proved the theorem. Now, let us find out that s of x is factor of p of x or not. According to factor theorem, if x minus 3 is the factor of p of x, then p of 3 is equal to 0. Since the root of x minus 3 is 3, on substituting x is equal to 3, we get p of 3 is equal to 0. Therefore, s of x is factor of p of x. Suppose these are factors of the polynomial. Therefore, we can represent it like this. Now, on comparing the coefficients, we get a is equal to km, b is equal to kn plus lm and c is equal to ln. That is, b is the sum of two numbers whose product is ac. Therefore, to factorize the quadratic polynomial, we have to write b as the sum of two numbers whose product is ac. I hope you have understood the concept very well. Thanks for watching this video.